Okay, so the last segment is on finding the derivative of the inverse sine function. Okay, so if I think of sine as a function from reals to reals, then it isn't one-to-one and onto, so I have to restrict its domain. And we'll see that with all the other trig functions that we need to find derivatives of and the inverses, the derivatives of their inverse functions, we're going to have to restrict their domains and ranges. Okay, so we're going to use a restricted sine function. This sine function maps from minus pi over 2 to pi over 2, including the endpoints, to minus 1, 1, including the endpoints. Okay, this sine function is one-to-one and it's also onto, so it has an inverse. Okay. This inverse has various names: inverse sine, asine, or arc sine, or sine to the minus 1. Okay, so if you see sine to the minus 1, it doesn't mean 1 over sine, it means the inverse function of sine. Okay, so sine to the minus 1 maps from minus 1 to 1 to minus pi over 2 to pi over 2. Okay, it acts in the opposite direction. And as usual, the inverse function acting on the original function acting on x leaves us with x for x in the domain of the original sine function. Okay, so x is taking, again, let me remind you, x is taking values from minus pi over 2 to pi over 2. Okay, and similarly, sine of the sine inverse of y equals y for y in the domain of the inverse sine function. Okay, we're going to take the derivative using chain rule and implicit differentiation of that first equation. And when we do that, we will, as usual, we get that the derivative with respect to y of sine inverse of y is equal to 1 over the cosine of x. Now, it would be nice if we could get an answer completely in terms of y and not involving x. And so what we do is we're going to apply the trig identity, sine squared plus cos squared x equals 1, using y is equal to sine of x. So that means y squared plus cos squared x is equal to 1. Okay, well, if y squared plus cos squared x is equal to 1, then the cos of x is equal to 1 minus y squared, take the root, and then it's either plus or minus. Now it's one of those two things, it's not both of them at the same time. So we have to consider whether we want to write root of 1 minus y squared, or whether we say that cosine is equal to minus the root of 1 minus y squared. Okay, now let's go back. I remind you, x lies between minus pi over 2 and pi over 2. The cosine function, cos of x, only takes values which are greater than or equal to 0 on that interval. It doesn't take any negative values. So cosine can't be minus root of 1 minus y squared. So that leaves us with cosine of x is equal to positive root of 1 minus y squared. Okay, so then if we go back here, right, we had that the derivative with respect to y of the inverse sine of y is equal to 1 over the cos of x. And now we've decided that the cos of x is root of 1 minus y squared. So finally we get that the derivative with respect to y of the inverse sine of y is equal to 1 over the root of 1 minus y squared. And similarly, the derivative with respect to x of the inverse sine of x equals 1 over the root of 1 minus x squared. Okay, so that's enough for this session. Later in the next session, we're going to consider the derivatives of the inverse functions of all of the main trigonometric functions, and the steps required to find their derivatives are very similar to the ones that we've used here.